I would like you to design a web crawler. Hi, everyone, and welcome to another mock interview with Exponent. I'm here today with Ravi. Would you like to introduce yourself?
Sure. So my name is Ravi, as you introduced me. I have more than a decade of experience in software engineering, and I worked for a bunch of companies, including a couple of MAANG companies, and furthermore, other, I would say, MNCs I have worked with. I have got experience primarily in the back-end side of things, with a bit of front-end experience also. And about the tech stack, I have got very tech stack, which I have been working with. And I also like to help learners and students about job interviews, about any particular topic if they want help with. So I casually try to help them. Yeah.
That's awesome. Well, I'm sure your students are going to get a lot of value from today's question. Be sure to click the link in the description below to check out our new software engineering interview course. And we also have a library of data science questions, in-depth mock interviews for coding and system design, and peer-to-peer interviews that you can do yourself. So your question for today is, I would like you to design a web crawler.
Cool. So let's get started with this. I'll be sharing my screen. Just give me a moment. Okay, so just putting down few things for the confirmation. So we have to design a web crawler. Perfect. Okay. So just checking that the understanding which I have about web crawler, precisely what I get is that there is a particular I would say tool, a particular technology which kind of we feed certain initial URLs to it, and it takes them as the starting point and kind of follows all the links, tries to resolve those URLs which we provide to it. And accordingly, the idea of a web crawler is it tries to go through all the pages available on the internet and kind of put a certain, data about them so that it can be used for further process. For example, primary use case, I think, is a search engine. They primarily use a web crawler. So is that understanding correct?
Yes, that's right.
Okay, great. Perfect. So I would just ask a few questions here with you just to confirm or clarify the problem a bit more further. Since we are processing URLs, which we'll be providing to the web crawler, and accordingly it will find further URLs, do we need as I mentioned, one of the examples for the web search engine, do we further need to process the URLs for maybe any ranking or any indexing purpose as such?
Yes, we will.
Okay, great. Okay. So why I asked that question is because it will give me the idea if I need to provide a certain storage, if I need to think about the storage perspective.
Okay.
Great. Okay. Fine. So is it something like a manual kind of thing, like once we trigger it, then the crawling should happen, or do you want it to happen on certain fixed schedule wise kind of?
I think it should have a regular schedule to update the records, and we need to also set a delay for certain websites that we're visiting for the politeness policy to take that into account.
I see. Yes. That makes sense because if we kind of keep crawling certain websites like a lot, maybe there'll be a lot of traffic and it might incur a lot of cost on that website. Yeah. Okay. Makes sense. Fine. Another thing which I'm thinking, which we may clarify, and by the way, I forgot, I will just keep a note of all these things. So we need a fixed schedule for crawling. We need to process the URLs. Like we have a further need, I would say. So in that sense, like we need to store the URL data. Is what I was assuming. And okay. So do we need to treat all the websites, because there are different types of websites? There are sports websites, news websites, and educational websites. Do we need to treat all of them like at the same level? For example, like the crawling behavior, should it be same for all of them?
Good question. I think we need to prioritize the crawling in some way, and let me know what your rationale is, how you would want to differentiate some of these websites. Like, for example, news will need to be crawled a little more regularly. And how would you rank other types of websites in that hierarchy?
Yeah, okay. Fine. Yeah, that makes sense. Definitely. So basically, some websites need frequent crawling, I would say. Yeah, and I would say like a certain order. If I can think about, like, definitely news websites do need to be crawling because the data on those websites changes very frequently. Whereas other websites, maybe some, for example, some static websites, not exactly static, but then, for example, some website which are like a photography based website, or maybe they are some Wikipedia kind of a website, let's say, some blogging websites. Now, they don't change very often, as frequent as news websites. So I would put them a bit lower in the hierarchy, or in the priority order, I would say.
That makes sense.
Yeah. Okay. Okay. I think this is a good lot of requirements. So I still think one final thing that I can clarify here, that duplication, because there might be URLs which are directing to the same website. There might be potentially different website having the same data. So do we need to kind of take care of duplicate pages, like not crawling the same page twice, those kind of scenarios?
Yeah, we should avoid indexing the same page.
Okay. Fine. I will definitely take care of duplicate web pages. Okay, fair enough. I think these are good enough, I would say, as far as the core functionality is concerned. These requirements are good enough, I would say. For the non-functional requirements, so I'll just name it like functional ones. These are the functional ones. For the non-functional, I will assume the regular ones, like probably being scalable, available, highly available, and all. Those are the ones I will assume. But do you have anything else that you want to add for the non-functional?
I think on the point that you just brought up about indexing the same page twice, let's look for performance optimizations where the system should be smart enough to avoid visiting URLs that it's already seen before. I'd like to see what that.
Okay. Performance also should be taken into account, and we need to have like some kind of smartness to avoid visiting same URL. Okay, fair enough. Cool. Thank you so much for all of these this clarity. I think the requirements are pretty much summarized. Like, we need to have certain scheduling based crawling. We need to definitely, I would say, keep some data stored or some information stored about the crawled websites and the URLs. Then we need some way of prioritizing the crawling. Certain websites need to be crawled more frequently than others, so all that frequent crawling and all I need to take care, and obviously the duplication. So I think these are fair enough, and obviously the non-functional requirements. So great. I think I can get started. Let me talk a bit about some capacity numbers. So how many web pages in total do you think we should be taking into account?
Let's assume for that 1 billion, and then for other numbers, you can feel free to make assumptions and just justify.
Okay. Fair enough. So let's say, I would say that maybe, as you said, 1 billion web pages is what we are concerned with. And while crawling, now this boils down to that, how much is the size of each web page, I would say. So I will assume, since you said that, I can make certain assumptions. So each web page, I would say, is around, let's say, 100 KB, maybe 100 KB. 100 KB should be fine. Now, with this into perspective, like, this is the average size of a web page that I'm considering, and assuming that, let's say, there is some frequency, like every on an average, we crawl every 10 days or maybe a week. Obviously, I will talk about certain websites, the crawling will be more frequent. But on an average, let's say a week, we are crawling or we are refreshing this. So that means that we have 1 billion. So I would say, so let's say, I would put it this way. I'm bad with the number of zeros. So 1 billion into, let's say, each page will be 100 KB and 100 KB and 1 billion websites. And I would also put into perspective that each website has different number of pages also. So again, on an average, I will assume that they have 100 pages. On an average, each website has 100 pages. So with this calculation, I think, okay, million 10 to the power of 6, billion will be 10 to the power of 9, fine. I think with this will be 100 KB, right? Into 100 KB. So kilobytes into bytes into gigabytes, okay, bytes to gigabytes, then, megabytes to gigabytes, okay. I think this will come down to be 10, okay, 10 into 10 to the power of 9, if I'm not wrong. I think, okay, ultimately it will come down to, I think, 10 petabytes. 10 petabytes of data in, I would say, in the given frequency. Like, for example, every 7 days that I took on an average, that we are recrawling every 7 days. So I would assume that every 7 days we are dealing with so much data, 10 petabytes. Because let's say after the next 7 days when we again crawl, there might be a new data, there might be a fresh data, but on an average, like, this is the data, 10 petabytes is what we will have to deal with, to store or to take care of every 7 days kind of thing. Let's say for the given frequency, I'm assuming this frequency to be 7 days right now. So that's the storage. Now, okay. Now, when I say this is, let's say, 7 days, now there are like around 52 weeks in a year. I would take this down to be something like, okay, 10 petabytes in 7 days. So I will just divide it by 7. So that would come up to be somewhere around 1.3 petabytes a day, actually. And if I divide that by the number of seconds in a day, which is around 86,500, I'll just round it off to 100,000. I think we will get somewhere around, if I'm not wrong, somewhere around approximately a 3 GB per second. Now that's the bandwidth that we are dealing with. So ultimately, with the capacity numbers, I wanted to arrive at what is the storage that we are dealing with and what is the bandwidth that we are dealing with. So does this look good to you? Any questions?
Yes.
Okay, fair enough. Okay. So with this into perspective, I think I will move further ahead, and I will do some design part now. So what I will do here is that, maybe for the overall design. By the way, I'm thinking of API discussion also. Although while for this one, I am not very sure, do we need to go into too much details of the API, but maybe as I discuss about the services in the detailed design, I will time and again bring out the relevant APIs which are needed for the particular service probably.
Okay.
But, I'll skip this discussion for now. So discussing on the high level design for this. So I'm just thinking what components I'll be needing here. So few things which I can think of is, since there is demand for scheduled crawling. So I think one of the components that I can for now think is there would be a certain component called scheduler.
Mm-hmm.
Again, I'm not right now going into the details. I'm just listing out the components and what they will be dealing with. We'll discuss in details later on probably. But there might be a scheduler, and then this scheduler will be responsible for, it will deal with the schedules when the crawling should be happening and all. Now, once, let's say, the crawling starts, what is going to happen? I'm just thinking from that perspective. So we will need to visit websites. That means I can clearly see that DNS resolution is something which is going to come into picture here, because we will have a list of IP addresses ultimately, and we need to resolve those IP addresses into web pages, into URLs actually. So something like a DNS resolver can be needed, I will say. Yep. And I'll just pull it a bit more down so that we have the space. Okay. All right. So the DNS resolver basically is going to give us the list of IP addresses, which will be serving that particular website. Now, once these worker hosts receive those DNS, those IP addresses, I should say, they further pass it on to maybe another component, which we can call, let's say, the fetcher. Fetcher will be responsible for essentially hitting those IP addresses, communicating with those IP addresses which are serving a certain websites probably, and retrieving those web pages in HTML format maybe. And once they retrieve it, they put it up onto the storage. So on a very high level, this is how our crawler will probably work. Now, one of the requirements that we have, if I go back to the requirements, is that we need to have it at fixed schedule. Now, obviously, the scheduler is going to deal with that requirement, but one major thing is, our opportunity which I see here, is that the scheduler actually will consist of, I would just come down here and draw here too. So our scheduler component, this essentially is our scheduler. Now, what this will comprise of is, I would say, this will have, I would say, a queue. This component will consist of a queue. And I would also add a SQL database to this one. Now, what's the need here is because this, I'm thinking, will serve us two purposes. One is that in the queue, we can store the information about the URLs. It can be a kind of a priority queue, actually. Priority queue, which might be used to specify the priorities of the websites. For example, news websites might have, as we discussed, might have a higher priority. Similarly, sports website, they also might have a higher priority. So we might have different queues for different types of websites. So that might be one possible solution. Otherwise, again, if that's not feasible enough, we can have simple, entries like, for example, URL as the key, and the value can be like P1, what's the priority? What's the priority? And it can be like a tuple kind of a thing. So the key might be the URL, and the value would be the priority, and maybe the next crawling time of that. So next crawling time would signify that the frequency of crawling for that particular website. So let's say for more frequent, the websites which have more priority, actually the next crawling time, essentially like either of these two, I think the priority also will signify the same thing. So either we can have P1 indicator kind of thing. So let's say if it's a P1, probably in our logic, we can define that something which is a P1 needs to be crawled every 5 seconds, every 10 seconds, something like that. Or we can signify that with specifying directly the next crawling time for the website also. That if the next crawling time, if it's a more prior website, then we will keep the next crawling time as shorter one. I mean, I hope you get the idea there. So using these two indicators, we can definitely set the priorities of the website and differentiate between different websites. So that's one thing. I think that's taken care of. The SQL database, the relational database, will be used to store the URLs along with these parameters, either the next crawling time or maybe the priority. Now, database will get populated. Like we will pick out the URLs from the database and populate the queue. And accordingly, as the data is present in the queue, like this seed URL which I mentioned, you can think of this, that this is what I'm representing as the queue. This will contain initially the seed URLs, and going further, it will actually contains the URLs which need to be crawled. So seed URLs are there just for the initial starting purpose. But till the time the data is in queue, the workers will keep on pulling the data from or URLs from the queue, and accordingly the further process will go on. But SQL database will store our URL information with the priority or the next calling time related information, and the scheduler component, which comprises this, it will continuously push the URLs as and when the next crawling time is near. It will push it then to the queue so that the worker can take and start the crawling. So that's how the scheduler will behave, I would say. Cool. Then I will quickly talk about the DNS resolver. I think nothing much to talk about it. We discussed it already. It will simply just take the URL, give you the list of the IP addresses which are serving the URL. Essentially, the worker hosts are responsible for taking the list of IP addresses, and they ultimately act as an interface, as kind of a gateway between this queue or the scheduler component and this fetcher component, where they just have to pass on the IP addresses to the fetcher component. So,
is there any complexity involved in the DNS resolver?
Okay. So when you say complexity, yes.
When you're talking about the overall system complexity, so that's fine.
Yeah. We can discuss that there also. But yes, definitely. I think your question was also valid. Just addressing that very quickly. That DNS is definitely a time-consuming process, and if we go with ready-made or third-party solutions, we may not have complete control over it. So depending on how how fast we want the performance to be, since performance is one of the requirements, I would say that we can go with a custom DNS resolver, which we can build ourselves and accordingly have complete control to modify the performance and all of those things.
I would say let's assume for now that we're using something out of the box, but let's just take that into account when we're checking the complexity.
Sure. And we can also maybe, by the way, also include some kind of a caching here in front of DNS resolver, so that some IP addresses which are queried more frequently, we don't need to hit the DNS resolver all the time. So that couple of things can be done. Okay. So at this point of time, I think yes, we can go to the extra fetcher actually. Now, fetcher once it receives the HTML, I would say, information from the related IP addresses. I think we cannot directly just whatever information we have retrieved, we cannot directly just pass that to the storage. I think because of the fact that there are URLs within the web pages also. So it's kind of a recursive way that the crawler functions, that with the seed URLs, it tries to find further URLs within the given web pages, and then it goes on further from there. So I think we need to kind of segregate things here. When I say segregate, I'm talking about extracting the HTML content and the URLs separately, and accordingly pushing them to the storage so that we have the actual HTML content of the crawled web pages and also the further links that we might need to crawl later on. So we need to look into that. So that way the extractor will also be needed here.
Go over that just one more time. What's the purpose of adding this extractor here? What was the problem you were trying to solve?
Yes. So fetcher will give you the HTML pages, the web pages, right? Now, a raw, I would say a simple web page will contain some information, probably some text information and some media information. But then it further contains certain reference URL also. Within a web page also you have certain URLs. So it is kind of a recursive way that you want to keep on crawling, and that is how you expand your reach to the entire www World Wide Web. So this extraction process take the HTML or the actual content separately and keep these reference URLs so that you can use them for further crawl.
Okay.
That's the problem I'm trying to solve.
Got it. Sounds good. I'll ask the further questions later. I think this is interesting.
Sure. Sounds good. Okay. So moving on further, I think one of the aspects here, which we definitely need to think about, and going back to the requirements again, that we need to take care of duplicate web pages actually. So we have taken care of fixed schedule, which we can definitely specify using these next crawling time, and the scheduler component will accordingly take out the URLs from the SQL database and put it in the. So I think we have taken care of these things, fixed schedule, and some website needs more frequent crawling and all. I think duplicate web pages, taking care of that is something which we need to look into. Now, when it comes to duplicate web pages, I think one thing which I can check here is that if I have, one of the core problems is if I get a certain URL, I need to check if I have seen that URL before or not. Now, one of the things that I can do, like in the storage, we will be storing the URL separately. We can go one by one, compare against each stored URL that, okay, does this URL or is this URL already present? That's one way, but that will be I would say very, very time consuming, because then we need to go over all the entries. That will be O of N actually. To reduce that, I think hashing can be done. We can create a hash of each URL and store that, which will be kind of an O of 1 lookup. I think that might be a possible solution. Does that sound good to you? Or if I talk about taking care of the websites previously seen with the hashing solution?
So you're suggesting hash the URLs and then check to see if every word that you encounter already exists in your hash table, and what's the complexity of that?
Well, I think that will be O of 1, but that should be O of 1 is what I feel. Yeah.
Okay. I think we could have hash collisions with this, and that means probably worst case complexity we're going to be looking at is O of N. The tables could also become fairly gigantic because we're storing so many URLs in that storage. So we'll have additional latency there for a read and write, especially if it's on a disk. So just take that into account.
Yeah, I think that's a very, very valid point. Okay, so I'm just rethinking here that the problem statement here is that we just need to check if we have seen a certain thing before or not. Just so that we can, so we are looking into some kind of building that smartness to avoid visiting the same URL. I think, this also should be taken like avoiding the duplicate, but I think avoiding the duplicate is a bit more nuanced. I will talk about that. But I think right now I'm trying to cater to this one that we need to avoid visiting the same URL. So the problem that we are trying to cater is we just need to check if that thing is present or not. And when I think on from that perspective, I think a particular data structure comes to my mind, which is Bloom filter. Now, Bloom filter again is a very probabilistic data structure, and it obviously does not gives you a definite answer, but it kind of gives you an estimate that something like 90% chance if the URL exists, but then 100% chance if it does not exist. So it kind of gives you 100% assurance, like if you're looking that if the URL exists or not. So if it does not exist, it will be 100% true for sure. But yes, if it exists, it might not be giving you the exact answer. So the problem statement here is never heard. Yes, yeah. That's a very good data structure actually. Yes. So since we are trying to avoid, we are trying to cater to that, we should not do a duplication. So if the URL does not exist, if we get an answer regarding that, I think that way we can definitely take a decision of avoiding the duplication. And in that sense, I think Bloom filter fits perfectly well in this scenario. So we can totally use a data structure called Bloom filter to store our URL information, and accordingly, what we retrieve from the fetcher, we can compare against the stored URL information in the Bloom filter, and as we get the go no go kind of a status from the Bloom filter, we can accordingly decide. That will be a better way, I think, to deal with the URL not seen before, and we can totally avoid this visiting the same URL again.
And your complexity of the Bloom filter compared to the hashing, what would that be?
Yes, I think that will definitely be O of 1, even if because it's kind of for the negative scenario, negative in the sense I should call it positive, that if the URL does not exist, it is kind of 100% deterministic in that sense. And it deals with, setting the bits actually. So it also goes around some hashing, and then with that hash, it sets the bits information 0 and 1 kind of a thing. But then, the way it works, actually, I can totally go into the details if you're interested, but
that's fine. Yeah, I don't think we need to go into the details of the Bloom filter, but good to know that, okay, so that's the complexity that we're looking at.
Yeah, like it's definitely a better complexity than hash map, for sure. Yeah, cool. So that way we can do that. Now, going further, I would say that I will just complete the remaining pieces. So once we have the extractor, I think one of the part of duplicate elimination is that even when we have retrieved a certain URL, so there might be possibilities that URLs are different, but they are having the same content. Right now, what we check if the same URL we have visited before or not. So certain websites might fox us by having the URL as different, but the content would be the same. And in that case also, we should be looking into avoiding duplicate storage, that we should not be storing the same website or same content again and again. So I think from that perspective, we can implement some kind of logic. So I would expand upon this extractor. I will zoom down on this extractor here, and we can implement some kind of a logic of checksum logic here in this extractor, where against each extracted web page, it will have to pass through a certain checksum. We can use I think Murmur is a popular algorithm when it comes to checking the checksum kind of thing, and MD5 is also one of the popular ones. I might be wrong, but yes, there are some popular algorithms using which we can calculate the checksum for a particular web page. And if let's say, even if the URLs foxes, that the different URLs are having the same web page or pointing to the same web page, we essentially can pass the web page through that checksum. And if we find that more than two web pages having the same checksum, we know that they are the same content, and we can discard them. Actually, we can take a decision that yes, we don't need to store this particular website because we already have it. So that is another way of dealing with duplicates, I would say. That having said that, I'm just rechecking. So going back to the requirements here, 6 schedule I have taken care of. Processing the URLs, so we are storing the URLs in this scheduler. We have a SQL database, so we are taking care of that. Probably some website needs frequent crawling. We have taken care of that. We need to take care of duplicate web pages. I discussed 2 scenarios regarding that. So regarding the storage, actually, I should be discussing on this. For this SQL storage, I think I talked about the data model already. Like it might have URL, and another column would be probably next scroll time, which will be a time, timestamp kind of a field. URL would be a text or string kind of a field. So that would be the data model for this SQL database. For this storage, I would use primarily a blob storage, like an S3 kind of a thing, because HTML data, ultimately what we are getting from the web pages, that more or less, I think, suits well in an object storage kind of a format. That is best suited as an object storage. So I would go for an object storage. So this storage essentially is what I'm saying is we can have an object storage to store our actual web pages. Okay. With this extractor, we can obviously, introduce a couple of storages of this for this duplicate elimination. For example, we can have a storage which deals with I would say checksum storage, so that it is storing the checksum of all the different websites that we have stored, so that when this extractor has extracted the actual website content, it can check against this checksum storage that are we going to store duplicate or not. And accordingly, if there are no duplicates, so then this extractor will ultimately go and store the actual content in this object storage, I would say.
Okay.
So that way we can deal with this. I think overall this looks good. I believe we have covered all the requirements that we had. Do you have any questions? Anything that you want to talk about separately?
Let's talk about recrawling. How and when would we need to recrawl?
Oh, that's a good question. Yeah. Absolutely, yes. So because initially we'll be just providing some beginner level URLs just to get the web crawler started. But then later on, when it kind of has the initial part done, then later on it needs to kind of operate in a self automated kind of a way. Like now it has the content and it kind of needs to crawl over and over again for that. So I think a better way to go about that, as I suggested, that this extractor, the purpose of this extractor is to extract the web pages information and also the reference URLs. So once it finds the URLs, I would say once it finds the URLs in the web pages, I would say that it would definitely compare. Okay, I'm just checking. Yes, we can go back. We can have a feed. We can have a feed from this extractor to this. I would say to this particular storage. I think I should be drawing out a component here, the SQL database. And the reason, by the way, I went for SQL is I think for this scenario we can go for just having a rethought. Is that we can go for a NoSQL, a simple key value kind of a store, because the way I see the data model is that it can simply be satisfied with a key value also, the URL and the next crawling time probably. So what I'm suggesting is that this extractor will extract the web pages. It will check against the checksum. Accordingly, it will store the web page content in the object storage, but the URLs which it extracts, it will pass it on back to this NoSQL key value storage. And accordingly, this scheduler component will keep on checking if the queue, if the queue has space, if the workers are pulling out the URLs for crawling from the queue, it will accordingly keep on, checking in this NoSQL KV and populate this queue accordingly. So the ultimate answer here would be that as long as there is data in the queue, I would say the recrawling will happen. So essentially, I would say that recrawling is done in order to, I would say, first of all, facilitate or take care of if the websites are changing the data, if the data on the website is changing. And when it would happen is when your queue is, let's say, becoming full or near it is going to become full, like let's say there is a threshold, we can decide on the threshold according to the business use. And as the queue size crosses the threshold, recrawling would kick in, I would say.
Okay, got it. And is there any scenario that you can see where someone can attack this in a specific way to exhaust the system?
Okay. Okay. So when you say exhaust the system, are you talking about like we keep on continuously just crawling a certain web page, maybe, probably, because some web pages have like multiple pages actually, not just a single. Okay. I think that's a good possibility. I think that is a good future consideration that we definitely can think about to safeguard our system, or not only safeguard our system, but like let's say some website, very complex website has like 1,000, 2,000, 5,000 pages maybe. We cannot just let our crawler, keep on crawling all those 5,000 pages, because ultimately it will be a loss of resources on our side actually. The network bandwidth is getting utilized and whatnot. So we can think of building some smartness, I would say. Just thinking out loud here is that there are two factors in this. One is that the number of pages, a certain website can have an exhaustive number of pages. other thing is, so we can tackle that by limiting or setting some smartness that, okay, if we have crawled X number of pages against a given domain, against a given URL, we should not be crawling further. We should not be crawling further for that domain, So we can limit that. We limit that crawling for a particular domain if we have crossed the threshold. That can be one thing. And I think for that, crawler technologies have a specific file called robots file, which kind of dictates or gives the instruction, kind of a do's and don'ts for the crawler. So the crawler accordingly, whenever it starts recrawling, it refers to this robots file and accordingly behaves or carries out the crawling as it is specified in the robots file. So the threshold that I was speaking about, I think we can mention something like that in the robots file that, okay, if against a certain domain, if you have crawled more than a number of pages, I think you should just limit it. Just stop your crawling.
Okay. I think that's a good strategy. I think we can stop here. This is a pretty cool system that you've designed. What are your thoughts?
Overall, I think this is good. I'm happy that I could cover all of these requirements that we discussed. Obviously, performance-wise, we could cover scalability-wise. We can have multiple workers and we can have replicas for different components. So I'm happy that I could cover a lot of different components. Probably API discussion is something which I missed, but the fact that I'm acknowledging that as a candidate, I think that would convey my intentions to the interview.
I think that's good enough. Like if an interviewer really wants to dig into something like that, they will prompt you to do that. Note about the performance. I think it's really cool that you had this new data structure to talk about. I'll make a note for anyone watching that you don't have to know like the newest, fanciest data structures. Just be able to call out what the performance is. That's it. If the interviewer wants to prompt you and make you optimize something, they're going to ask you and give you direction to do that. But I think, I just don't want anyone to take away from this that, oh my God, I need to go and like learn all the new fancy data structures. It's super cool that you knew that and very, very interesting to bring it up in an interview scenario. And that's definitely, I think that's a bonus, but it's not a requirement for anyone watching this. And that kind of goes for pretty much anything that you're doing in these interviews. As long as you can call something out, justify it, provide the information that you have about it. You don't have to know everything in the world in order to pass an interview. You just have to show that you can do logical thinking. This was awesome. Yeah. This was a really cool interview. I think your students and the viewers who are going to watch this are going to be very interested to see the system that you've designed. People can approach this in a bunch of different ways, and there's variability in how people approach their design. So I think that's the coolest part about these interviews. So thank you so much, Ravi.
My pleasure, Nima. It was great talking to you, and I really enjoyed solving this problem. Thank you so much.
Awesome. Thank you very much.